Hello and welcome to the AppSec Error Loop, how we can stop repeating common security mistakes. If you are joining us live, our speaker is in the Slido discussion answering your questions right now. For audio or video issues, please click the technical support button found below. I'd now like to turn it over to Peter Danhue for the presentation.
Hello and welcome everybody. I think normally I would be enjoying a black pepper crab in Singapore, but this year it's obviously not going to work out that way. So welcome to the AppSec Error Loop. My name is Peter. I'm the CEO and co-founder of Secure Code Warrior. I've been in this industry for roughly about 20 years. Early 2000, I started working on software security, and I want to share a little bit my journey on why we are still here in this error loop and how we can basically fix it. Now, I'm not sure about you guys, but whenever I open up my digital newspaper, I see a new data breach every single day. And to be honest, I started to become a little bit insensitive about those breaches because another week, another breach, another millions records been disposed, and I just glance over it and kind of roll my eyes and say, well, it is what it is. Now, I think we're in this situation because we've been using duct tape for too long. And what I mean with that is, remember camping gear? When you go camping, there's a hole in your tent. Well, you fix it with duct tape. Now, you do that 100 times. After a while, your tent is basically going to not function that well anymore. And I think we've been now in this space for roughly 20 years, and we're still making a lot of basic, simple security mistakes in software. And the approach we've been taking for the past 20 years is just not working, and we need to change that. Now, before I go into some of the details, let's look at some of the statistics, some of the numbers around software security, because I do think it's important for everyone to understand the scale of this problem. Now, did you know that today there are roughly 24 million developers around the world? Now, I didn't count them. It was basically Evans Data that came out with a blog post in May this year. And basically, they're saying that we're going to grow from 24 million to 28 million people that are writing code. So in about 4 years, we'll be adding another 4 million people around this world that would be writing software. And it's not a surprise because a lot of the banks are turning into software companies. A lot of the car companies are turning into software companies. Basically, everybody is switching to digital and writing code every now and then. Now, CSO Online basically came out with another statistic saying, hey, we actually are writing 111 billion lines of code every single year. Now, don't ask me how they basically came up or counted that number, but that's an estimation. They're basically making 1,100 billion lines of code. Now, what we also know as security experts is that there's roughly 1 to 4 exploitable security bugs in 50,000 lines of code. Now, based upon statistics and things we've read on the Stack Overflow, that is a pretty scary statistics. Basically, these are not just bugs, these are exploitable security bugs. So things that hackers can basically abuse. Now, if you do quick math, that means 24 million developers, 1,100 billion lines of code, and this statistic, that means we are roughly releasing 2 million exploitable security bugs every single year. And we security people need to find a way on how to stop them and minimize them. Now, DHS says that 90% of the security incidents come from defects in the design or in the code that you're basically writing. And recently, Verizon came back with 2 statistics. One of them being, well, we have about 20% of the data breaches are actually caused by a security misconfiguration, an S3 bucket that is open, or something we've misconfigured, or basically a human error, a human mistake. And then I think the last one is around the data breaches. 20% of those are using known web application vulnerabilities. So these are not new type of latest threats. These are things that we've been known for a very, very, very long time. Now, how did we end up in this situation? Well, that's where I always kind of look back to software engineering as a profession. Now, how long have you been written software as a professional? I think it must be less than 100 years. So that means the experience we've built up in software engineering is basically less than 100 years old. Now, if you compare that with civil engineering or building houses, this is basically how we're building a house today. it looks nice, it's functional, it has cameras, doors, locks, and everything is basically there to protect the family and their assets. Now, this is the result of more than 2,000 years of house building engineering. So this is what we've achieved after 2,000 years. Now, I'm pretty sure that the initial houses we've built 2,000 years ago weren't safe, weren't secure. They were probably functional in some kind of a way. They protected you from the rain and from the big elements of nature, but they weren't really called safe or totally flawless. And I think we're in a similar journey with software engineering. It's a very young profession with less than 100 years of experience, and we're still learning very quickly about how to not only make functional and beautiful software, but also software that is safe, that protects privacy, and that protects data from customers and clients. Now, it's also pretty well known that when you actually fix or find a flaw, the later you find that flaw in your construction, the most costly it actually is. And it's the same with housing. Once you've built your whole house and then you start finding fundamental flaws in your security design, your security architecture, it is very costly to actually fix that. And it's no different in software development. The later you basically start with focusing on security, the more it is going to cost you, and the more it's also going to slow you down. I think NIST came out with statistics basically saying it is 30 times more expensive to actually wait until your software has been written, deployed into production, and then find a flaw than basically focusing on secure coding while you are writing or in your design phases of your software. So obviously we've been doing something wrong in the last 20 years, and hand on my heart, I'm probably one of the people that did it wrong in the past as well, because as I said, I started in security roughly 2003, and for a long time I was following the practices that I'm actually very much against nowadays. Now, one of the things I've realized is that the number of developers are actually growing way faster than the security knowledge distribution. That means there's way more developers coming into this market than that we can train them or that we can help them and spread that knowledge. And I think a big part of that is our university or academic system, that they need to start focusing and helping us with teaching developers around secure coding patterns. Very often, developers don't really have an accountability, or they don't really feel responsible for the security of their code. And I think that's basically the result again of the security people, because we've always kind of said, hey, you know what, we'll build the security function, we'll build it outside of engineering, we are the experts, we treat it as a black box. And I think as a result, we've kind of taken away the accountability of that. So many software developers are like, well, you know what, we got a security team that fixes those issues for us. And I'll tell you something about the challenges with that model. Now, if you're actually looking at the data breaches that are happening, many of them have software weaknesses that are 15 to 20 years old. So these are not new things. Out of my head, if you look at the OWASP top 3, cross-site scripting, SQL injection attacks, these are things that were discovered literally in 1999, so pre-2000. And we are still making mistakes against those old software vulnerabilities, especially in the IoT space, where we're now writing a lot of software for new devices. We are kind of finding back that old vulnerabilities like buffer overflows, like some of the injection attacks, are continuously resurfacing. And I think the main reason is because developers aren't really aware of some of the bad coding patterns. Now, if you look at software security today, what is happening around the world? What is happening in AppSec? Well, first of all, there is a bunch of technologies out there. You've got static application security testing, which basically means you're going to feed technology a bunch of source code, and it's going to scan for vulnerabilities. You've got newer things like RASP and DAST and IAST, basically a lot of acronyms that confuse non-security people a lot. So we've got SAST, RASP, DAST, IAST, we got bug bounties of crowd security testing. And we also got the fairly new DevSecOps, containerization, security pipelining, and everybody's basically shouting, hey, we need to shift left. Now, SAST has been there since 2010. I think that was when the first SAST scanners basically came out. Now, what are some of the problems we are facing with that technology? Well, first of all, most of the tools, to be honest, they don't work like they're advertised. And I'm talking kind of out of experience here. If you look at SAST, you need expertise to run the tool. It has a false positive ratio, which means that it often flags things that are not correct. Yes, it does flag vulnerabilities, but it often also flags pieces of code that are in fact not vulnerabilities because it is, if you simple it down, signature-based. It is also very slow, and it needs to support different frameworks. What it means that a SAST scanner for C++ very often doesn't support JavaScript or doesn't support Go or Rust, which means that with SAST, you don't really have a solution that supports most of those languages. So there's no silver bullet for SAST. Other challenges with IS and DAST, again, I think you need expertise. It has false negatives, so if you don't know what you're doing, you will be forgetting flaws, you will be bypassing it, and you won't basically detect them. And it's also slow. You then get RASP. Well, in my opinion, RASP is more of a web application firewall, next generation plus, something which is many people are basically trying to use, but nobody actually blocks it in production, and is also very technology specific. So I honestly think that with the technology we've built, it helps, it supports, but it is not a one-size-fits-all. And I think many people kind of make the mistake the first time they start investing in software security. What they do is they will fall back to, hey, let's buy technology, and let's see if the technology can actually fix this for us. So there's no one tool to rule them all. Not a single tool can scan for every vulnerability in every situation, and they're slow. Now, they have been useful because in a waterfall model, you can attach those scanners at the end, you can plug them somewhere in, and if they take an hour or even a day or even 3 days, it doesn't really matter because you're in a waterfall model and you're not really slowing down too much. Now, it's different in an agile environment where me as a developer, I want to write code and I want to publish it by the end of the day. That means those tools need to be fast, they need to be responsive, and I can't wait an hour to kind of see the results of my scan because I'm already working on something else. So I think that's one of the challenges we're currently having with some of those tools. Another thing, a lot of people, they kind of fall back to penetration testing. Well, I've been in pen testing for a long time in my career. I was teaching for SANS for roughly about 10 years in my career. And I'm going to be honest, pen testing mostly sucks. And the reason why is because the pen testers, or also the breakers, they are speaking a different language than the developers, which are the builders. Now, pen testers, security testers are really good into finding problems, pointing them out, and talking things like injection attacks and XSS and IDOR and a whole bunch of acronyms and languages that actually the developer doesn't understand. The developer he or she knows their code. They don't speak security. They speak about classes, framework, constructors, all that kind of stuff. And the problem is we've got a big language barrier between those two groups. The breakers, they can point out problems, but not many can actually fix them. There are a lot of breakers that can find injection attacks, but if you ask them, hey, how would you fix this in Python Django? They got no idea. How would you fix this into Node.js? They've got no idea. They will basically give generic recommendation. I think everybody heard about, hey, you've got an injection attack, you need to do input validation. Now, for a developer, it's basically useless advice. Like input validation is so broad, it's so unpractical. And the builders, they want to know what functions to use, what libraries to use, what patterns to kind of apply. And I think we need to fix and basically cross that barrier. And I think that's why I'm a bit concerned about most penetration tester people. You need to kind of lift up your game and start coding, understand how builders are building their code. And if you write reports, please give them recommendations on how to fix them more than something generically that you've copied from OWASP or any of those websites out there. Give them a secure coding pattern in the language and in their framework. Now, another challenge I notice in a lot of companies is AppSec very often is a bottleneck. Now, I don't know whether you're from the same age pattern as me, but this was basically how I was surfing the internet probably in the 90s. If you were downloading a file of 180 megabytes, it took about 39 years. Now, the AppSec function in the company is very much the same at the moment. You basically ask them to do something, and it will take a long time. And it's not that they don't want to move fast, but the thing is, they can't move fast. They can't scale. Now, if you look at the ratio between software developers and AppSec experts, it's roughly one AppSec person for 200 developers. And this is in a high maturity company that is investing in AppSec. So in many of them, it is 1 to 2,000, which is a far worse situation. Now, imagine you're in this company that's investing in security, and you need to work with 200 developers to make sure that their code is basically secure. It's basically an impossible task, because you can literally spend like 8 hours with one developer for a full year, and that's of course not going to help. So AppSec is a bottleneck. They are basically sometimes slowing down software development, and that's why it needs a different approach. So we will never have enough AppSec specialists to deal with the amount of code produced, because it is an impossible game to kind of win. It's basically, in my company, we've decided to not put up an AppSec team, but to build in software security into the engineering function. I think moving forward, that's what we'll probably have to do, is not rely upon a central function for AppSec, but making sure that AppSec is built into your engineering function. Now, today, when everybody thinks about AppSec, we're basically failing from learning from some of our mistakes. And I think the main reason because of this is that we are finding a bug, we are assigning it to a developer to kind of fix it, and then basically when that developer fixes the bug, that secure coding pattern that that developer has used to fix it, now there's one developer in the whole company that knows about this. But what about the 1,000 other ones? How are we going to make sure that they know about this fix? Well, very often we don't do anything with that. So we are basically having this black hole of security knowledge where one person finds a fix and that knowledge basically goes away. And that one person, if he leaves the organization, nobody else knows. And I think that's the reason why we have continuously been reintroducing the same vulnerabilities into basically code, because every time it is a different developer introducing a similar type of flaw in the organization. Now, one of the things we've done is on Secure Code Warrior, we basically have a platform where a developer can learn about secure coding patterns. And we support like 38, 39 different frameworks. And I've kind of started analyzing this data, because we now 5 years long, we've collected roughly about more than 1 million of those coding pattern challenges that those developers have played on our platform. Now, those developers come from roughly 400 enterprise organizations, and we've mainly looked at what we call the mature languages, Java, C#, Python, Node.js, and Ruby. Now, what was very interesting to kind of see is that things like SQL injection, people actually roughly 60% of the time, they knew about this attack, and rightfully so. It's something which is 20 years old. And the same with the usage of vulnerable components. It was correct 64% of the time. And that's actually not a bad result. But then if you look at the flip side, it also means that 42% of all those developers didn't know about this coding pattern that was introducing an injection attack from 20 years ago. And if you look at things like insecure direct object reference, like poor authorization rules, it was incorrect roughly 80% of the time. That means that 80% of your developers don't really know how to prevent these kind of flaws in code. CSRF, CSRF, or cross-site request forgery, which is a vulnerability, I think about 9 to 10 years old, was incorrect about 63% of the time. So it's obviously demonstrating that there is a knowledge gap that we have with developers, and we need to help them. We basically need to help them become better. Now, this is basically what everybody thinks that AppSec is doing, but in fact, this is basically what AppSec is doing on a daily basis. Now, how can you fix this? How can you basically not shift left, because you actually need to start left. You need to focus on making the person better, making the developer better. And how can you scale that and make an impact as an AppSec Pro? Now, if you look at athletes, runners, footballers, tennis players, they don't focus on fixing their flaws with a technology problem. They train. They basically they go to gyms. They nurture their food, and they basically continuously try to become better and better and better. And I think that's one of the things we probably need to start doing, is starting left and focusing on the individual developers. So in a perfect world, how does AppSec look like? Well, first of all, everybody cares about security. So there's a positive security culture. Very often now, you notice this constrained culture between security and developers. The developers don't really like the security people. And can you blame them? The security function always gives them problems and flaws, but never fixes. So we need to change that. We need to make sure that the security function is being seen as something which is there to support and help and provide them with secure coding patterns, rather than saying, hey, here's a pen test report, we've got 20 things and you need to fix it, or we're going to fail an audit. That's not a way on how to create a positive culture. So there needs to be shared responsibility, and important as well, what is noticed that a lot of developers, they don't get time to even learn about things like secure coding patterns. So we also need to make sure from a developer's perspective that they get the time to actually work on some of these things. Now, what can security do? Well, if you focus on the negatives, you are going to get a negative result. And what I mean with that is the whole problem around security testing or penetration testing. Don't give developers problems, give them fixes. Create them Jira tickets with advice. Create pull requests if you are comfortable in the framework to actually fix the bug. And in that way, you can actually help that that engineer to become better, rather than just shoving a problem and basically forcing them to fix it. Now, what is the right type of training? Well, I don't like sending people to a full-time week training and take them out of their work and basically have them emerge one time and then the rest of the year nothing. I think we need to find ways on how to train people embedded into their daily lives. Do it small, do it with micro-learning, do it contextual, make it fun, make it engaging, and the most important thing is make it specific to the language and framework that a developer is using. So if your developers are coding in Node.js Express framework, don't train them on generic Java training. That's not going to work. Yes, vulnerabilities exist in both of those languages, but the way on how you fix them and how you patch them is completely different. So that's why it needs to be framework specific. So it needs to be in the relevant language, relevant framework. If you use Go or Rust or Mobile or Play, or even the newer infrastructure as code languages, basically focus on fixing the top 3 vulnerabilities that you're finding in your organization, and make sure you can eliminate those. Imagine you can basically train every single developer to prevent the 3 top vulnerabilities you have in your company. How much time wouldn't that save for the organization? Now, change your mindset from weaknesses to controls, which means stop talking about the OWASP Top 10. We know it exists. It's been there for a long time, and it's a very useful resource for security awareness. but it points out problems. It's basically pointing out the negativity. What we should be doing is talking about things like the proactive controls for developers, the security verification standards. What patterns should you implement to basically prevent some of these flaws? Now, I think if you want to distribute knowledge, you need to do it at a point in time where it is useful to the developer and when they actually need it. Now, what better way to do it? To embed it into their tools, embed it into IntelliJ, JetBrains, embed it into Visual Studio, embed it into things like Jira and GitHub, because that is the moment where either inside the IDE, where the developer is writing code, that's where you need to say, hey, wait a minute, the coding pattern you're using here, you shouldn't be using it. It's actually a bad one to use because it can lead to a vulnerability. So that is a moment of micro-learning. You've got time and attention to demonstrate they can fix it. The same with things like ticketing systems, like Jira and GitHub Issues and ServiceNow. When a developer gets assigned a bug to fix, you have a little moment there where you can help them to become faster by, instead of having them look up on Google on how to fix an injection attack, well, provide them the knowledge saying, hey, Jira ticket, this is how you fix it. This is a secure coding pattern, so that you actually save them time from Googling and trying to find the right answer, potentially copy pasting the wrong answer from Stack Overflow. You're basically giving them the secure coding pattern. So embed this knowledge into some of the developer tooling. We need to create a culture of awareness. Yep, developers, we need to remain agile. We need to make sure that AppSec doesn't get frustrated. And I think if you focus on building security into the DNA of a developer, you're actually going to go a long way of changing that security culture. Now, I think one of the best examples I've seen in Asia Pacific, and props to Reuven and the team at DBS Bank in Singapore. They started working 4 or 5 years on improving the security and pushing that into the DNA of their developers. And initially they started with 30 or 40 developers, and they saw the results it got with that now they've pushed it out to 1,500 developers, and they're basically building in security into the DNA of every single person that touches code within DBS. And I think they've gotten very far with it, and I'm really proud of working together with them, but also seeing what they've achieved in a few years' times. So how do you apply this knowledge? Like, what do I expect that you can do next week? Well, first of all, if you have developers in your organization, go and speak with them and ask them what you can do to help them write secure code. Do they want tools? Do they want knowledge? Do they want secure coding patterns? Also ask them how effective their knowledge is around security, because many developers say, well, look, I know about security, like, don't bother me with these things. And if they do, then then leave them alone, as long as they can prove that the code that they're writing is basically secure. Now, while you're having these conversations, try to figure out which developers are interested in security and actually have good communication skills, because those are the ones you want to engage with as your champions or as your security coaches. Because if you have got 1,000 developers and you're only one AppSec person or one security function, you want to have helpers. You want to have people that bring out the communication and that basically push out messaging to those developers. So basically find those champions. Now, once you've had those conversations, one of the things you should try is basically focus on identifying your top 3 key weaknesses and figure out how to fix them in the main languages that you're using in your company. And basically make a page, make a document that shows your developers how to fix those top 3 languages in Java Spring, in Java Strut, or whatever language you're using in the organization. And you can use that as guidance, basically to say, hey, every single developer in our company needs to learn about those top 3 weaknesses and secure coding patterns to basically stop them. And you know what? Do that for 6 months, and after 6 months, measure the impact. Look with SAST or DAST how many tools or how many of those bugs basically come back, and you will be able to see a great result that you've been able to eliminate your top 3 weaknesses in only 6 months. Good. I hope this was useful. Thanks very much for listening, everybody, and happy to answer any questions on the live chat.